Hello everyone, my name is Wisam, and today we're going to be doing a TE tutorial on calculus optimization. So let's start with a practice problem. Find two positive numbers such that their product is 192 and the sum of the first plus 3 times the second is minimum. So let's start out by turning this word problem into variables. So we know that we have two numbers, so it's called an x and y. And we know that x times y equals 192, so let's get that out of the way. Okay, now let's take the second part. So now we have the sum of the first plus 3 times the second is minimum. So let's start writing that out into variables. So x plus 3y equals something. I'm just going to call it z in this case. Okay? So now I need to make the sum as small as possible. So let's first get x in terms of y. So that way we can replace it later. So we have x equals 192 divided by y. So far so good. Now I'm going to substitute this x for my y here in this the summation. So 192 over y plus 3y equals z. So we want to make this a minimum. So we know that if we get the derivative to equal 0, then we get a min or max. So let's start by doing that first. So if we take the derivative of this, we'll get negative 192 over y squared plus 3 equals z, equals 0. So now we're going to solve for this. Let's multiply by y squared all the way across. So we're going to get negative 192 plus 3y squared equals 0. Right? So now, let's see. So now we're going to take the 192 onto the other side, divide by 3, and take the square root. So let's do that. So we know that y is going to equal 192 divided by 3, and take the square root of that. So 192 divided by 3 is 64. So we have the square root of 64. And then the square root of 64 is 8. Alright, so we know that y equals 8. But we're not done yet. We still have to solve for x. So let's plug it back into this equation. And then we'll get that x equals 192 over 8. And that equals 24. So we know x equals 24. And that would be the first problem. Okay, so now let's do another problem. Same type, just different numbers and different wording. So find two positive numbers again, such that the sum of the first plus twice the second is 200 and their product is maximum. So again, let's use x and y. So we know that we're trying to maximize x and y equals z. And then we also know that x plus 2y equals 200. Okay. So now we have to solve for x, and then we'll substitute it into our other equation. So we know that x equals 200 minus 2y. So let's substitute that in for our equation that we're trying to maximize. So we have 200 minus 2y times y equals z. So now we're going to take the derivative. So we're going to use product rule. So we take the derivative of the first times the second. So we have 2 times y plus the derivative of the second, which is going to be 1 since it's just y, times this quantity, the 200 minus 2y. So 200 minus 2y. And we're going to set that equal to 0. Okay, so now let's collect like terms. So we'll have 200 minus 4y equals 0. So here it's pretty easy. We see that y is equal to 50 because we just do 200 divided by 4 equals 50 equals y. Okay, so now we know y equals 50. And then we're going to substitute it back in. So 2 times 50 is 100, and then x equals 200 minus 100. Let me write that out. So x equals 200 minus 2 times 50 equals 200 minus 100, and that equals 100. So x equals 100. Okay, that's the next problem. Okay, time for a different type of problem. So now we're going to deal with some real-life applications instead of just random numbers. So suppose you had 150 meters of fencing to make 3 equally sized pins as shown here, and we're going to maximize the area. So we know that we have 150 meters of fencing. So that's going to be the total lengths I have here. So I'm going to call this one x, and I'm going to call, let me put a little bar there, and I'm going to call this distance y. Since I know they're equal, I can use this to simplify the work a little bit. So I know that I'm going to have 1, 2, 3, 4 x's, 4 fences of length x, and then I'm going to have 1, 2, 3, 4, 5, 6 of length y. And I want that to equal 150. Now the area might be a little tricky here. We're going to do x times 3y. So our area is going to equal 3xy, because I just took the 3 from the y and brought it forward. Okay, so we're trying to maximize the area. So we're going to have to take the derivative of it eventually. But we have 2 variables here. So what I'm going to do is I'm going to do the same thing that we did in the last problem and simplify for x. So let's solve for x. We're going to get 4x equals 150 minus 6y. And I'm going to divide that by 4. So x equals 150 minus 6y all over 4. Okay? So now I'm going to plug this in for x. So we know that area is going to equal 150. Let me start with the 3 first. 3 times 150 minus 6y divided by 4 times y. Okay, now we have to take the derivative of this. Right now it's a little messy, but that's okay because we can pull out some constants. So let's pull out the 3 over 4. And now all we're left with is the 150 minus 6y times y. So let's do product rule on these two because we don't have to worry about the constant. So we know it's going to be 3 over 4 times, our derivative is going to be 3 over 4 times, so we're going to do product rule again. So this one's going to be, the derivative of this quantity is going to be negative 6, so we're going to get negative 6y plus, the derivative of this one is just 1 times 150 minus 6y, so we get 150 minus 6y. Notice how I have the 3/4 all the way out front because I took the constant out beforehand. So I don't want to just give it to the negative 6y. So we can simplify what's in the parentheses right now. So we're going to get 3 over 4 times 150. Terrible 5 there. $150 minus negative 6y plus negative 6y is negative 12y minus 12y. Okay? And we're going to set that equal to 0 because that's what we want the derivative to be. So now we can multiply by the 3/4 because we don't need that anymore, right? Because if we just multiply by 4 over 3 to 0, it'll still be 0. So we'll be fine there. Now we just have to solve for 150 minus 12y equals 0. Add the 12y over and then divide. So we're going to get 150 over 12 equals y. And that would be the answer for y. right? Okay. Now I need to solve for x. So I'm going to take the 150 divided by 12, and I'm going to plug it in for y here. So I'm going to erase some stuff because it's starting to get a little cluttered. But let's take this stuff out. Okay. So now we have 4x plus 6, and I'm going to substitute in the 150 over 12. 150 divided by 12 equals 150. 6 divided by 12 is 1/2, so we can cancel those off and put a 2 at the bottom to make it a little easier on us. And then we can subtract the 150 over 2 to the other side. So we know that 4x equals 150 minus 150 divided by 2. Since this is 1/2 of 150, we're going to just have 1/2 of 150 left over. So let's put that there. And then we divide by 4. So x is going to equal 150 divided by 8. And don't forget your units. So they told us we were starting in meters, so we end in meters. Meters and meters. And that's how you would do that problem.